Hello folks, welcome to CPDict. I hope everybody who is listening to me is fit and fine. In today's video we are going to solve the problem from the August LeetCoding challenge. Let's see what the problem is. It is called find right interval. What the problem statement says is we have a set of intervals consisting of start and end values. Start point where that interval starts and the end point where it ends. And for every interval we need to store the minimum interval j's index such that we want to find one interval whose start point is greater than equal to the end point of current interval, and we need to find one such interval which has the minimum such value of that starting point of that interval. And if there is no such interval in our in our main array or vector, then we need to add -1 for that particular interval's answer. And there are two constraints given which will turn this problem into an easy one. It says the start and end value of any interval cannot be equal, and also none of these intervals have the same start point. So let's see this example. It says 3 4 2 3 and 1 2. That is 3 4 2 3 and 1 2. These are the start and end values of here. We have three intervals right here. So for each interval we need to find one interval from all the other intervals such that the start value is greater than equal to the end value of that interval. For example, for this particular interval at index 0, among these two we need to find out one interval whose start value is greater than equal to 4, and we cannot find any such interval. So for this interval the output would be -1. Let's see the second one. We need to find out one interval whose start value is greater than equal to 3, and we need to find out the lower bound, that is the minimum such value of that start value. So among these two we have the first one. It has the starting value as 3, so the answer would be 0. We need to print the index of that interval, as index of this interval is 0. And for this interval, this particular one, we need to find out interval from among these other intervals such that their start value is greater than equal to 2, and we have two of those right here. One is 3 4 and one is 2 3. Now it says we want to find out the minimum such value, as 2 is lesser than 3, so the output would be we need to find return this interval which is at index 1. Let's see what was the answer. Yes, it is -1 0 and 1. We need to return this array. Now let's see what we can do to solve this problem. First of all, what we can do, we can maintain a vector of pairs. Vector of pair in which the first value signifies the start value of all the intervals and the second value signifies the index of that interval. So I am maintaining this vector of pair, and then I will sort it. After sorting, we are sure that the values would be arranged in ascending order of start values, that the starts value will be increasing order. If we are sorting in increasing order, obviously we will try to use this data structure to find out the answer. Okay. Yep. So let's try to save some space. It is start and it is idx. Now this part we have done this. Let's just build the array for this example, which is 3 4 2 3 and 1 2 and 1 2. So if I sort them according to start value and my second value is the index, first of all let my see my start the vector, let's call it as starts, the name of this vector. Now the value of this starts before sorting would be 3 0 2 1 and 1 2, and the second value here represents the index of that interval in our array. Now after sorting, the new order will be 1 2 2 1 and 3 0. This is what our start array would look like after sorting. Okay, now we will try it. We will build our own custom binary search function, and then for each of the intervals right here, we will pick up the end value for that interval. Let's say it is x. Then in this vector we will try to find out the index of, like in this vector we will first try to find out the value whose start value is greater than or equal to x. Okay, and if we are able to find any such value among this pair of values, then we will return the index. We will return the second value. If we find any such pair whose first value, that is the start value of that interval, is greater than or equal to x, then we will return the second value of that pair, which is the index of that interval, that array. Let's see for 3 4, if we do our binary search, or let's say search operation here, we cannot find any value. For 3 4, the value of x is 4, as the end value is 4. Now we cannot find any pair here whose first which is the pair which is having the first value greater than or equal to 4. So the answer would be -1. And for this interval 2 3, here x is equal to 3, we find out that we have a pair here whose starting value, whose first value is greater than or equal to 3, then we will return 0. That is the index of that interval. So that for this the answer would be 0. And for third 1 2, here the value of x is 2, that is the end point of that interval. If we search it in this our start vector, we'll find out that this is the first interval we find, and then we return the index of that interval, which is 1, and the answer would be 1. And to find out such pair from this vector of pairs, we can use our own custom binary search operation. How we will try to implement it, I will explain it via code, or let me just try to explain here what we can do. So for each of the intervals, you will be doing binary search on this start vector, and it will take log n time, and we will be doing it for all the intervals. So the time complexity would be n into log n. And also initially as we sorted the array, it also resulted in n log n. The total time complexity will also be n log n. Now the way we can binary search that value among the start vector, what we can do, suppose we have a value x which we want to search, and this is the L and R index, that is the starting and the last index where we want to search in our current function call. We'll first try to find out mid, which is L plus R equal L plus R by 2. Suppose mid is somewhere here. We'll compare if the interval present at mid index, if its start value is lesser than x. If the start value is lesser than x, then we'll go ahead. That is, we only care about the right part, because we want to find out any interval whose start value is greater than or equal to x. Then we will increment our L to mid plus 1, and then we will make another recursive call as we will be implementing our binary search function using a recursive function. And in another case, suppose the first value present at the pair at index mid is greater than equal to x. Now we need to see whether there are any elements on the left side as well whose first value is greater than equal to x. If we are not able to find out any such value, then we can simply return the second value from this pair present at mid index, because on the left part, if we are not able to find any such value, then simply return this one right here. And if on the left side we are able to find any interval whose start value is also greater than equal to x, then we need to go to the left side as we need to return the minimum such start value. It was mentioned in the problem. Then we will decrement our r to mid minus 1. Okay, let's see the code now. Yep. So yes, I am maintaining a starts vector, which is a pair of int and int. First value signifies the start value of that interval, and the second one is the index in the main interval vector, index of that interval. Okay, so I have populated my starts vector, then I have sorted it, and implicitly by default it will sort it according to the start value first and then to the index. We do not care about the index value as all the start values are distinct, as it was mentioned in the problem statement. So we just want to sort it according to the start value. This part is done. Now I'm initializing or declaring an answer vector, which I would be returning at the last. Now for each of the interval, I'm doing a lower bound binary call on my start vector for the end value of that interval, as intervals I1 signifies the end value of that interval, and if it is returning -1, I'm returning -1 from my custom function if I'm not able to find any such interval, and I'm pushing -1 to the answer. Otherwise I'm pushing the index of that interval, which should be returned in my binary search function. From my binary search function, at the end I'm returning answer. Let's see the binary function now. Yep, I found mid first. I see that if the value present at the index mid of the pair, the first value, which is the start index, is lesser than value, then we need to go further. Like that is, we need to go to the right side, as we want a value which is greater than equal to value, like any start interval whose value is greater than equal to, well, then we'll go to the right side, and if we have come to this point, it means the first value of that pair is greater than equal to value. Then we will see if it is the first element of our vector, or if the element which is just to the left of this mid contains or stores a lesser value, then simply return the index of current pair, because we are sure that on the left side we won't be able to find any such possible interval. We simply return the index of this current interval, and if we are able to find any such interval to the left side, so that even there the start value is greater than equal to x, then we move to the left side. Then we decrement our r to mid -1. So yep, as I mentioned earlier, the time complexity would be n into log n. If you liked this video, then please do subscribe to our channel. I've seen that around 87% of our viewers have not subscribed to our channel, so please do so. And yep, take care. Sayonara. See you in the next videos.